My pleasure to introduce Kathryn. She's a geologist with over 15 years experience in the industry. After 2 years in WA working gold and nickel as a junior, she started Jundee as an underground production geologist in 2011. She progressed her way up to the Project Resource Geologist, leading the on-site team and proceeded on the role of senior mine geologist and underground superintendent. Kathryn opted for a change of pace and moved to the corporate office, where she took the role of Project Resource Geologist from Jundee while she started a family and went on to be promoted to Senior Geologist Resources. Following 12 years at Jundee, Kathryn transitioned to the Thunderbox and Browns Wing operation in February 2024. So please welcome me, Kathryn, here to the podium. Yes.
Right, today I am going to be speaking to you about Gortys 4s and my non-linear transition from Vulcan to Leapfrog and then into Datamine. Now a quick background on the area. Gortys 4s project is approximately 30 kilometres southeast of the main Jundee mine and plant and 5 kilometres southwest of the operating mine of Ramone. Gortys 4s has had open pit mining in the past and has 14 open pits. Currently, Gortys 4s is a Jundee growth project that's trying to move to production in the future. Now, talking through the history, in the 1980s, Wiluna Mines explored the area, finding Gortys 4s. It then went into production in 91 to 94. When Newmont took over, they did open pit mining at both Gortys and 4s from 2004 to 2007. The final resource model for Gortys was in 2010, and after Northern Star picked up Jundee and its surrounding projects, they did a resource remodel and revision and reclassification in 2016. In 2017, they did more drilling and remodeling of the resource area. In 2020, a pit optimization was done, but unfortunately it was not economic to mining due to the gold price, strip-back ratios, and some other factors. In 2023, the growth team decided to improve the geology of the area, so targeting along strike extensions to help with pit cutbacks, and along with a better gold price to see if the extensions, Gortys 4s can be turned into an economic project for the Jundee mill. This meant that a new block model was required for combining Gortys 4s area. Now, Gortys 4s sounds simple. It's just Gortys 4s. But not everything is easy as it seems. On the left here, we have Gortys on the top, which comprises of 7 deposits and 7 open pits. 4s on the bottom here has 9 deposits and 7 open pits. Now, we needed to take a complicated area and simplify the geology. Is quite a hard task. Luckily, we were able to merge some of the basalts together, unless there was a density issue, and then use Leapfrog to do the porphyries. Now, this is shown on the right-hand map here with the geology loaded up in Leapfrog. This is the drilling completed by the Jundee growth team in 2023, with the highest grade intercepts shown in colours below. The drilling was targeting along strike extensions to the main deposits and some down dip extensions as well. Due to the drilling being scattered all over the area, a large update to all the deposits was required. Now, being a large area as Gortys 4s, there was a lot of data to work with. So the raw data set had 14,000 collars, 346,000 samples, and only 8,600 of those were diamond. Now, the database comparison, so the 33 diamond holes that we've included for down dip extensions, these are previously excluded. Now, nothing was wrong with them. They were just focusing on the top 200 metres and did not use them for the underground diamond extensions. With the 64 new RC holes that we were completed in 2023, I was now moving from number of mineralised wireframes, pre and post, from 2,110 to 2,228. Now, as anyone knows, it's a huge task to do any sort of block modelling with those sorts of numbers, you get a little bit scared. So, talking about the purpose. So now we know a bit of where Gortys and Bors is and its history. We need to understand why we're doing the update and the transition. So as I've spoken before, the purpose of the update was to combine Gortys and Bors into one model, to update the interp with the new RC holes and diamond underground holes, and now to transition from Vulcan to Leapfrog interp and to Datamine estimation. The reason for the transfer or the transition was that at Northern Star we have moved to transitioning everyone to standardisation across all sites. This helps with movements of geologists from site to site being on just purely Leapfrog, interp and Datamine estimation. With Jundee, with 25 over years of Vulcan on site and 12 years for myself. Now, with all these sites moving to Leapfrog and Datamine, I had a decision to make. Do I wait until this happens at Jundee and learn then with my colleagues, or do I get on the front foot and learn alone and transition first? Now, the latter was my path. It is not an easy path, but it meant that I wasn't going to be left behind being part-time as I'm a mum of 2 young kids. I did the transition with peer mentoring from my team in the office, the Datamine online learnings, and the Leapfrog and Datamine intro and fundamentals training. Now, with 12 years in Vulcan, I was terrified of losing all of my knowledge and experience and starting fresh. Now, the rest of my presentation will go through the transition process and my personal experiences through it. So this is the software transition chart. I first saw this chart at the 2023 Northern Star Geology Conference, and it was presented by Marnie Matthews. She was going through her own transition in the Pogo mine, transitioning from Vulcan to Leapfrog. Now, there's a clear linear process starting in denial, going through acceptance, relearning, and then into integration. My journey, however, was not so linear. The progressions and regressions throughout the process made it hard to see light at the end of the tunnel. Now, for my own transition, I printed off and cut out a picture of my head and put it on my laptop. This helped me visualize my journey, but it was also really fun for others to come and slide me back down to anger when I'd had a particularly bad day. This was quite often. Now, starting in denial, seeing integration at the end is quite hard, but I can assure you it can happen. Right, now, wireframes. 2,228 was my number. Just looking at the sheer number of wireframes is terrifying. Now, imagine you're also learning a new software. This was my reality when I opened up the Leapfrog project from the growth team. I entered the fear stage quickly and abruptly. How was I going to tackle this? Now, the growth team did a phenomenal job. They imported and backflagged all of the wireframes. They updated the interp with the new drilling, extensions down dip, adding an additional 120 loads, and did import some static meshes for loads unchanged to speed up the process. So again, next, my task was reviewing the interp. How do I start? Where do I start? And what do I even need to do? Not knowing how to review people's work in a software program that they knew better than I did. It was incredibly intimidating, but using my general knowledge of interp review as being a senior resource geologist, I had to get it done. I used my team around me and asked for help from the ever-talented Zoe Reed-Lindroos, who's not here today, but she was my go-to Leapfrog guru. However, there is a downside. She had a very good knack for finding errors in a 1-minute spin and looking at it going, that looks a bit weird. The fact that she could so clearly see my problems that I hadn't been able to made me bounce between fear and anger on the stage of my transition. Was I good enough? Why didn't I see it? Now, incorporating the underground diamond holes, it was easy to extend interp with a simple selection and extension to boundary strings. The Gortys 17 load shown here, the previous shape in dashed lines, it has actually moved down slightly more than it was supposed to, But extending it down dip with the inclusion of the diamond holes with a simple selection opened my eyes to the benefit of the different workflow and how fast I could extend loads. It started to move me towards the acceptance and openness, just for a brief period. Now, it wasn't just the software change that I was going through. It was also that I've been working in underground mines for 14 years, my entire career. I was suddenly on the surface. The importance of topography, regolith layers, geology surfaces were all unknown to me. And yet another thing that I had to learn. Back to fear I go. Now, learning the Datamine lingo. So, learning software is one thing, and learning what buttons to push, but I also needed to learn the lingo and language as well. I was in a transition meeting for the poker team into Datamine, and I got 45 minutes into a data prep session, not knowing that data prep meant compositing. Now, this is a Northern Star workflow term, but kept getting tripped up on small things like this. It made me feel quite incompetent and that I was never going to know what's going on. Once I ended up doing my data prep, however, it took 4 hours. Now, to the sheer number of drill holes and loads, this set me into the anger massively. It was one of my first things I had to do in Datamine. Moving on to the geology models within the Northern Star workflow, I couldn't understand how many models we possibly needed. There was regolith models, there was lith models, there was domain models, rock models. How many models do you really need? But it wasn't until I had an issue later on in the process and I was able to quickly fix one of the models before merging it into the others, I could start to see the time saved and the improved benefit of the new workflow. Right, now to compare the two workflows. In Vulcan, on the left-hand side here, it is a nice streamlined workflow. You've got one block model to work with from start to finish. You put all your information at the top, you make your nice block model, you put all your variography details into it, and you get an estimated block model at the end. Now, very, very smooth. One that I do slightly miss. Now, with the Datamine workflow, we have multiple. Your proto at the top with all your block coordinates and your block sizes. The next is your 3 models. You've got your topography, your regolith, and your lith models. Now, all these 3 combine into what we call our rock model. Our domain model has all your loads, and once combined with your rock model and gets estimated with all the estimation parameters, you finally get your estimated model. Now, on the left-hand side for you guys, yes, is our estimation workflow as well, which is what we use from our macros. Now, each one of these has a tab in our spreadsheet, which is shown below down here in the green. This is our data prep screenshot. Now, I realized the beauty of the workflow when I could add in a line. So in a perfect world, you have all of your wireframes finished and ready to go before start block modeling. However, reality can be quite different. Trickling in of wireframes or last minute changes can be quite challenging to get everything out on time. I realized the beauty of the Datamine workflow when I could slot in another line in a spreadsheet, run my domain model again, instead of having to recreate the whole block model from start to finish. And now at Gordas Falls, this was really important because we had last minute changes to topography and to other loads. I started moving towards the testing stage of my transition. The master macro. Now, this is a huge 5,857 lines of code. Opening this sent me straight back to the fear stage, feeling like I was throwing away 12 years of experience on how to run a block model and just being a newbie again. Having to lean on others who I just met after coming back from maternity leave and feeling competent and slightly annoying. Now, this set of code was built by the masters within Northern Star Resource team, And me coming in at the end, it was quite hard to understand how they just got here. But it's the small building blocks that have been added and continually improved over many, many years. Learning code is not easy, but I had an amazing team surrounding me, all willing to help be my translator. Now, on the right is our estimation workflow. It's not a small feat to get one of these models to run and to the standard that we strive for here at Northern Star. I started moving towards acceptance and openness when I saw the potential of having one big block model for the whole of Gordes and Vors. Previously, there are 7 disjointed models pieced together. Gordes in one in the north there, and Vors was split into 6 individual block models and then combined into one. Due to having one big large block model, I needed a way to break up the deposits and make it more manageable. Using my Jundee knowledge and experience, I grouped the wireframes into geographical and geostatistical domains. This way, I was able to evaluate the areas within these geostats domains, making the estimation easier to manage and help streamline the workflow going forwards. I again was in the testing stage and starting to feel like I was finally on the way up. Now, at Jundee, domains are groups of lodes or mineralized zones. In the Northern Star Datamine workflow and Leapfrog workflow, individual lodes are domains. Not confusing at all. The DOM IDs are their unique identifiers for everything going forward in our block model. A new challenge presented itself with previously 7 block models, all with lode number 1s. Now, with a new block model and a unique DOM ID required for block modeling, I had to create a unique lode name and DOM ID for each of these 2,228 lodes that were also able to be connected to their previous block models and lode numbers. This was a very tedious and difficult path. I had to use the name of the previous block model, the lode names, geostatistical domains, all to help concatenate to make a new DOM ID. Now, as above you can see, the 24001 lode. Now this is in Vors, in the Mansell deposit, and it is lode number 1, which equals 24001. Now having all these DOM IDs finally sorted and having known which lode and model it was previously, I started to become the queen of VLOOKUPs and concatenates. But this stage sent me back to resistance. It was a really big challenge to find each of these unique DOM IDs and to fully understand the functionality of what it was going to be. With a 5 by 5 kilometre block model with over 2,000 lodes, I wasn't quite ready to debug a macro that I had no idea what I was doing and to deal with long wait times. So I came up with a plan. Start with big blocks and a few lodes, just one for each of the geostatistical domains. Run through the macro all the way through to the end. This way I was able to debug and learn the macros with short rerun times. Once the macro wasn't spitting out any errors, I went into smaller subblocks with the same amount of loads. This helped review the volumes of validations between the block models and the wireframes, as well as making sure that the repeatability was still there. I then moved on to small blocks with all of the loads. Doing one block model, but doing it multiple times, I got familiar with the process and was enjoying the repeatability of the Datamine estimation workflow. I moved into the testing stage again of my transition, but I was determined to stay back up here this time. Now, at Jundee and in Underground, we try to do nearest neighbour, inverse distance and ordinary kriging where possible. So when doing Gordes Vors, I tried to adopt the same method. However, using 2,000 loads, it wasn't just plausible. So when my manager asked me why I was doing it, I had to stop and think. It's because that's all I knew. Now, with the Jundee workflow, you need 3 different estimation runs, 3 separate top cuts, and this is built in from the beginning. With the Northern Star Datamine workflow, the repeatability of the estimation means that you can change the estimation type or top cut quite easily and rerun and compare. In Vulkan, we used individual BEFs for each load. These are bespoke, and changing parameters for multiple can be time consuming and due to them being in forms, as you can see here below. In the Datamine workflow, we can update the spreadsheet, rerun the macro, meaning it is very easy to have different sensitivities and compare them. Integration stage, my favourite stage. Validation is such a huge part of the estimation process, one that previously had taken a lot of time. One of the best features that I found through my whole transition process is the ability to load multiple block models and being able to use the quick filter to check for the DOM IDs with the composites loading grade, rescats, comparing against previous models, which Vulkan just cannot do. So I'm going to show you a little video, if I can make it work. So here you can see the main loads in the Thor Trend 1 Geostats domain. I changed the selection to just the DOM ID for the 23101. Now this may take a moment as the block model is quite large. This changes the block model and the composites to just this one load. Now looking in long section, I can go over to the sheets and toggle between the two different block models and compare the difference between the two. Now this made it really easy to visually validate and see the differences between rescats from added drill holes and in areas where we had no new information, trying to make the estimation as close as possible. Now there's a few other things that I got to in this integration stage. Now the repeatability and quickness of the estimation among some of the other processes made a huge difference in such a massive area such as Gordisvores. Forms and spreadsheets. The big difference in the estimation workflows is the fact that Vulkan uses forms and the Northern Star Datamine workflow uses spreadsheets. This means we can easily copy and paste during our estimation process, but also means you can go back to previous models and use their variography or other search parameters. Now, as you've heard from the beginning, my journey was not so linear. I had many progressions and regressions along the way. Now, the learnings from these helped me move forward and allowed me to understand the differences between the softwares. One of my regressions, one of the first ones, was learning for large processes to run overnight, like data prep. Now, I work a 6-hour day, and with a 4-hour data prep turnaround time, you need to do these things at the end of the day. It was very frustrating when coming in the morning and something had broken or not run properly, and 2/3 of my day was taken up with this. Selecting data within a wireframe, reporting or changing parameters was quite difficult and time consuming within the Datamine workflow. Now, with any new software, learning new tools can be a challenge, and I found this particularly hard with the sectioning tools, as I needed to use them so frequently in such a large area such as Gordisvores. And my final learning and regression was learning to use the short keys for things. Now, Datamine has a huge number of short key functions to do instead of finding a button. But this was yet another language that I needed to learn. Now, all of these things sent me back to the fear and anger stages. But it's realizing that there's a way through it. And like most things, it just takes time and practice. So, in summary, I transitioned from a Vulkan-only geologist to a Leapfrog and Datamine advocate. Looking back at the project, I've learnt so much, but if I tackle this again, I wouldn't choose such a complex area to do my first Datamine block model on. Takeaways from people starting their own transitions. It takes a village. Try not to do this alone. My team here, my wonderful team at Northern Star, with the shared skills in the group, helped me through the highs and lows, and I'm so incredibly grateful to them all. Now the final thing was understanding the transfer of skills, realizing that my 12 years wasn't being thrown out. It was just being converted into a different package. But the fundamental skills were all still there. But it took going through this transition to realize this. Thanks.